Hi, I'm Anthony Eden, the founder and CEO of DNSimple, a domain management automation platform for all of your domain name and DNS needs. Today I'd like to talk about what it's like running a Rails application for more than 10 years. First, I'm going to go through a little bit about the history of DNSimple and a history of the DNSimple application. Next, I'll go into software design choices, so the initial design choices that I made early on, followed by how those have changed over time as the team and application have grown. Next, I'm going to talk about the evolution of testing in DNSimple, followed by the evolution of how we operate DNSimple. And this has had a dramatic impact over time on both the design of the application as well as the design of the system as a whole. Then I'll talk to you a little bit about dependency management, about how we did it early and how we did it later, and how we do it now. Then I'll talk about some of the team changes over time and how this has impacted the design of the application and its ongoing operations. And finally, I'll talk a little bit about the future and some of the challenges that we still face today. So first, a little bit about the history of DNSimple. The DNSimple application is a Rails application that was first created April 7th, 2010. That was the initial commit. In the beginning, there was only one developer working on the Rails application. That was me. The other person who helped create the business was working fully on the operations side, so primarily the DNS infrastructure. From the initial commit to the launch was about 3 months, and that was a minimum viable product with only DNS services built into it. So over those first 3 months, I made a lot of decisions based on the kind of best practices of Rails at the time, and I'm sure I made a bunch of mistakes along the way, as would be expected. Let's go over some of those early software design choices now and see how they've changed over time. During those early days, I was following what were essentially the Rails best practices at the time. The first example I'd like to show you is the use of the thin controller fat model. And the thin controller notion is an excellent idea and one that I think holds true even today. The fat model idea, while fine for small applications, becomes a little bit more difficult to maintain for larger applications. Here is an example of the register method from one of the earliest versions of the domain model. This was used to register a domain name. It takes the extended attributes, if necessary, for the domain. It creates an options hash, passes that to the purchase method that is inside the upstream provider model. And then if that return result includes an order ID, a non-nil order ID, it will set the registration status to registered, save the local model, and return the result of that save. Otherwise, if there is no order ID present, it would return false and log the error. Or if an exception occurred, it would also log the error and return false, as well as updating the errors on the model. This is what the controller looked like. So this would call the register with the extended attributes, and if that was successful, it would deliver an email notifying the customer the domain was registered. You can see already that I wasn't truly following the thin model concept, because here, after this happens, the subscription is charged for the registration, and that logic is still inside the controller. So we can see already that the more complex business logic was already slipping into multiple places. In the early versions of the DNSimple application, I also use active record callbacks fairly extensively. Here's an example of using an active record callback to create or destroy a subscription in Chargeify, which was our payment processor at the time. And you can see that before create, we'll attempt to create it in Chargeify first, and then if that succeeds, it will set the Chargeify subscription ID. And the before destroy will attempt to cancel the subscription in Chargeify and then log an error if that fails due to an exception. Finally, one of the other elements of Rails that I used early in the application was direct access into the active record query interface. And this could be done from lots of different locations, from controllers to models to even to library code in certain cases. Here's an example of looking up a service object. In this case, this is for a one-click service. And you can see that it's fairly complex logic. It decides whether it should use the service ID or the ID itself from the params, depending on the context. It also decides whether the scope should be from within the domain's services list or all services. And then finally, it makes a decision about whether it should use find or find by short name, depending on whether the ID was numeric or a string. This is pretty complex. And this was buried inside of the application controller. And then in other cases, there would be code that would be inside of the controllers themselves. So now let's take a look at the different sort of negative outcomes of some of these decisions. The first is the use of the thin controller fat model results in God objects. So what those are is they are fairly complex and large models that have a lot of different behavior built into them. And a couple problems occur when we start using these types of God objects. One is that they're hard to understand because they have lots of different responsibilities. Another item that comes up is that they're hard to evolve because all of these complex interactions between the different methods inside of these God objects. In the case of active record callbacks, often the callbacks reach outside of the area of responsibility for the model and therefore create tight coupling between the model and some other part of the system, again making it difficult to both understand and evolve the system as a whole. And the direct use of the active record query interface, again, makes it difficult to understand how to find queries, how to maintain them if they need to be optimized for any reason. It makes it difficult to locate those. We often see inconsistencies in the way that the models are queried if there's not one place to go to try to get this type of information about the models. So how did we deal with some of these problems? Well, first of all, at one point we decided to introduce the notion of commands. And so commands in the traditional pattern sense are an encapsulation of a particular action. And typically it's designed to be something that's done and undone and redone. Now that was, if I recall, even creating these first versions of the commands and thinking that's how they'd be used. They ended up being used more like a collection layer for getting together different business logic and sort of providing integration from different components. But let me give you an example of how this looks today. So here is how the contact create command would be called today. And all of the commands follow the same pattern. You execute them, you give them as the first argument a context, and then additional arguments come after that. And the execution context might have information about, for example, what the current account is, who's logged in, whether they're accessing it via the API or the UI, things like that. This is an example of the early version of the contacts controller, where instead of having a command, the items inside the controller would be used directly. So I chose a simple example just so that it was easy to see how this changed from before and after. Before, we would build the contact inside of the controller directly, and then inside of the respond to would save the contact, and if that failed, we'd do one thing, and if it didn't fail, we'd do something else. Now it looks more like this, which is we call the command and we get back a result, and the result always has a data field, and we can determine if that result is successful, which is also a common part of the interface, then we can take one action, and if it is unsuccessful, we can take a different action. Here is an example of the actual contact create command. So you can see that the command instance method only takes the account and contact parameters. So these are all the arguments after the context. The context is stored inside the command and made available to everything inside that command. And so you can see here the implementation now creates the contact directly. And if that succeeds, it will also send out a notification. So I think this gives a good example of how the commands allow us to evolve the implementation to include cross-cutting concerns and remove those from the controllers themselves. And so in this case, the cross-cutting concern is the event notification, which in turn triggers things like webhooks and emails and things such as that. You can also see that at the end, the data is ensured to be set to the contact itself. And if there are any failures, that is inserted in the result as well. Now, in a simple implementation like this, the value might not be as clear as a more complex implementation. So I'd like to show you just the execute method of the domain registration. And here you can see it's far more complex. It has a lot of different behavior inside of it. And this is an example of how this has evolved over time. It includes different types of filtering for error handling, different preparation, a lot of complex logic that if this were to be in the controller, we would very quickly end up with extremely long and difficult to use and test controllers. Another item that we added was the notion of finders. So this is based loosely on the repository pattern, the idea being that you have one place to go to look up various collections or instances of any particular model. Here's an example from within the contacts controller, and you can see that the caller calls into account contacts listing with the account, and this returns a consistent method of listing the contacts that we want to see relative to a given account. And so this one method can be used in different locations whenever we need to list the contacts and have the full list for a given account. It'll use the same filtering and the same ordering, and that's an important part of why this works. Here you can see the evolution of how this would look over time. So initially it was pulling from the user. In the past we had only users, then we added the notion of accounts, and we redesigned the system so that all of the entities would be attached to the account rather than the user. We can see here in the second version, though, that ordering was still set right here in line. And by moving to the third version, all of that is encapsulated in one particular place and is easy to reuse. Here is a portion of the contact finder. You can see how the account contacts listing calls on another method inside of this finder to use the scope to actually get the contacts for a given account. And so it reuses that as well internally. And then you can see an example on the contact model here of the listing method and also the scope for account. So what finders really become is a place where you can collect together different pre-designed scope chains so that you can know that you're consistently finding the right object or set of objects. Next, I want to talk briefly about the testing in the early days of DNSimple and how that has changed. In the earliest versions, I used a combination of Cucumber and RSpec to test. I leaned very heavily on Cucumber, and I was writing the test more as acceptance tests and less unit tests inside of RSpec. So here's an example of an early acceptance test that shows that a user can activate their account. It has a description of what the feature is. So as a user, in order to use DNSimple to resolve DNS lookups, I can activate my account. Has background, and then it describes a scenario. And this would actually walk through the interface to execute this scenario. And here you can see an example of just a portion of the domain spec. This would mostly test the relationships, ensure they existed, the validations, and it also might do some other testing as well, either for regressions or for very specific behavior. Ultimately, though, as the system grew, we deemed that it was too time-consuming to maintain the Cucumber tests. They were difficult to maintain as the interface changed, as the experience changed, as the application changed rapidly. And thus, at one point, we decided to remove that. So now what we do is we generally use RSpec for both unit and integration tests. Now, doing this has its pros and cons. As you can imagine, running the entire DNSimple test suite is pretty slow. The good news is that we can run focused unit tests, but there's still a lot of room to improve here as well. And this is always one of the biggest challenges as application grows. Unless strong effort is put into making true unit tests only inside of your unit tests, you're going to end up with some mix of integration and unit tests. Also, if you only have unit tests, you'll probably end up running into problems with integrations because you have nothing testing those. So there are, again, pros and cons to mixing these two together, but this is a choice that we've made over time, and this is where we are today. Next, I'd like to talk about the operational evolution of DNSimple. In the early days, we used both Postgres and MySQL. So how did that work? In the case of Postgres, this was our primary data store for the DNSimple application. So this is what Rails was talking to for storing all of the data related to its models. And we used MySQL as the storage mechanism for our DNS servers. So every zone would be pushed into a MySQL database, and that in turn was used by our name server software to pull those zones and present them to customers. And this was for the DNS interface, so this was our authoritative name server interface, if you will. We also had a very different setup for our web server software. In the early days, we were using Mongrel. And along the way, we also started using Thin and ultimately ended up with Unicorn. And so that's what we've been running for many, many years, and it's worked out fairly well for us. But that change had to be handled inside the Rails application as well. And now we're considering moving, in some cases, to some newer web server software that supports concurrency, which again will force us to look at our application and figure out, okay, what sections of the application are not going to properly handle concurrency well. In the first versions of DNSimple, operationally, we used Rescue for background jobs. We decided ultimately to switch to Sidekick and then Sidekick Enterprise. And during that transition, it required us to change our application to remove the direct dependency on Rescue, which in many cases was embedded directly in the code. So we would call a class level method on Rescue itself. And after the transition to Sidekick, all of that was encapsulated inside of an interface that was less bound to any given background processor. Another major shift in our infrastructure was our authoritative DNS. So in the early days, we were using only a few virtual private servers, and those would talk, as I mentioned earlier, directly to a MySQL database in order to get their zones. After a few years of operating this way, we moved to what's called an Anycast system. So this is broadcasting IP addresses, the same IP addresses for all of the name servers, and distributing more of those servers across the world. So we moved from virtual private servers to bare metal servers, and then we distributed those bare metal servers at the time across 5 different locations around the world. So this actually had a significant impact on how we had to move data around. Writing data to a MySQL database no longer really worked that well. So we moved to distributing data to our edge systems for lots of different reasons. 1, for performance reasons. 2, because we wanted to make sure that we could get that replication out to the edge as fast as possible. And so this has worked fairly well, but even that, we still see further evolutions. Now, how does this impact the Rails application? That's primarily through the changes in the application and how and when it triggers changes to the zones to the edges. And that recently has gone through a major overhaul as well, so that messages are sent with only the data that they need, so we don't have to refresh zones as well. And this required, again, changing the interfaces that we use internally for sending messages to the edges. Next, I'd like to talk a little bit about dependency management. Any application that's going to live for a long time that has external dependencies is going to require some thought into dependency management. In the very early days, dependency management was essentially ad hoc. So that is, there was no process for managing dependencies. Occasionally, somebody would go in and say, oh, we need to update dependencies, and they would update one or many dependencies all at once and test and verify that those didn't break things, and that was it. This included dependencies such as the Rails application. So the early version of Rails that we used was 2.3, and now we're running 6.0. So as you can imagine, dealing with Rails dependencies was something that was very difficult to do in the early days, especially as it was going through changes that were significant. The same can be said for Ruby. We started with version 1.8 of Ruby, and now we are running on version 2.7. So evolving the application through those dependencies over time meant applying changes, and often in the early days, this was done very ad hoc. After we moved towards a larger team, we started dealing with dependencies in a manual but well-defined fashion. So we started creating policies internally for how we would change dependencies or how we would maintain them. This also included reducing some of the number of external dependencies that we had that were unnecessary, and that helps as well. But we still have quite a few external dependencies. So the manual dependency management turned out to be a little bit more difficult than we'd hoped. The good news is that nowadays there is automated dependency management. And so we use Dependabot inside of GitHub to basically regularly update dependencies. It will create pull requests for us that will have everything ready to go with the dependency. And I believe right now we are going through even patch versions automatically. And we have it in some cases, in some of our applications, but especially the Rails application. I believe that we have some dependencies that are updated on a weekly basis and some as they come out. And so this has helped massively to deal with dependency management, because now we can essentially just review those dependency changes, and if everything looks good and the test pass, then we can go ahead and roll those into production fairly quickly. Next, I want to talk about team changes. So this actually is probably the biggest impactor to the changes in the Rails application over the years. The first version was written with one person, and that was me, and we didn't hire or bring in our first hire until 2 years after the first version of the application was written. And already bringing in that first hire brought in fresh ideas and started to encourage improvements in the application code as a whole. Any new person who comes into an application is going to they're going to have to learn how the application is structured, and they're going to quickly find all of the dragons within, and they'll start to suggest, hey, we can look at this and maybe improve some of this. In addition to bringing people in, the reality is that any application that's going to live for a long time is going to have contributions of code from people that are no longer with the organization. And that presents another set of challenges, because you have to start to think about, how do we ensure that our code stays consistent so that people coming in can understand what was put in there from people who have left. And so this is one of those challenges that we continue to deal with every day, because every developer is going to have slight variations, if not significant variations, in their style of how they're going to write software. And so we've developed a set of style guides that are internal for how you write different parts of the DNSimple system. And we're always trying to evolve those style guides and those guidelines for how we build parts of our system so that they can change with the times. But you need to have something in place that sort of sets some boundaries if you want to maintain consistency in your application over time. And there are still areas in our system that are very difficult to understand, maybe overly extracted or what have you, and the person is no longer there, that we have to deal with and maintain. So again, developing a good set of standards that the team agrees to follow and ensuring that those standards are well communicated with the team will help to deal with this issue. We also see a lot of different skill levels and expertise of team members coming and going, and this has an impact on the code as well. So somebody who has a lot of experience writing applications, maybe in languages outside of Ruby, is going to see things very differently and have different suggestions on how to evolve the code than somebody who has spent most of their career in Ruby, as an example. Same with the difference between a senior engineer and an early engineer is going to be significant in the type of code that they're going to produce. Now, over the years, we've dealt with this in different ways. Right now, what we're trying to do is we're trying to encourage better information sharing, pairing more often between team members, and even in some cases doing mob programming so that we share the way that the code is written and do that more often as a team. As the team has come and gone as well, as different team members have come and gone, we also see that strong opinions can often cause friction when it comes to the code. And that's not necessarily a bad thing. So having strong opinions is good, but it will result in challenges inside it will manifest inside the code itself. So for example, if you have somebody that has very strong opinions about certain types of patterns and they want to use those types of patterns, well, they might come into the system and we aren't using that pattern, and that's okay, but that's going to potentially cause some friction because in a complex system, introducing new changes means that you have to make the decision. Are you going to slowly roll out that change into the system? Are you going to make larger changes? And these are one of the things that you'll have to navigate as your code base ages and gets larger and larger. We also have to deal with a lot of consistency issues and lack of documentation. And this is something that is very common, including was for us in our early code base. Very little was documented. Again, I think this is the difference between a product that is moving rapidly to try to evolve and something that has grown and become stable. And so over the years, different team members have brought in concepts that have helped make our system more consistent. So that means that when you go from one area of the code to another, you should know what to find when you get there. And for documentation, we have a lot more documentation now that is both inline in the code that explains maybe some of those areas that are a little bit more complex, as well as documentation outside of the code. We maintain a team wiki where we collect together sort of our guides for how you develop inside the DNSimple application. And consider that we have more than 27,000 commits and we're still growing. This has been a challenge and continues to be a challenge to keep this system from getting out of control, but that's part of dealing with an application that's been around for so long. So let's talk about the future. What kind of challenges do we face now at DNSimple? And I would say some of these challenges are the exact same ones we've always faced. Your first biggest challenge, or our first biggest challenge, is going to be dealing with legacy choices. So any choice, any decision that you take today, if it remains, is going to be a legacy. It's a legacy choice. And some of those decisions can cause a lot of friction in the future. So an example of that is a partial implementation. So sometimes we have ideas, and this includes code that I've brought in as well as I've seen it from pretty much every team member, where they have an idea about a change that they want to implement in the system, and they will apply that to one part of the system. And because there is a limited amount of time in each day and each week, each month and each year, and we have a lot of different goals, we have to decide, okay, are we going to try to expand the use of this to other parts of the code? And in many cases, we did not. So for example, the early implementation of the commands patterns that I showed, that was only in part of the system in the early days. And that actually caused a lot of trouble because it was unclear to somebody coming in, well, do I use a command or do I not use a command? And at one point we made the decision, we said, okay, we're going to overhaul the remainder of the system to add commands where they aren't being used today. And that was a time-consuming process, but ultimately resulted at least in consistency in the system for that particular pattern. We have other cases where we've yet to do that. And so partial implementations are a part of any system that will exist whenever you have many people touching that system. Another challenge that we face is just managing complexity. So as systems grow, they become complex, and it's hard to maintain the system if it becomes so complex that you can't understand the whole system in your mind. And that's the case today. And so now we've started doing is we've started focusing on how can we break these larger systems into discrete subsystems. And there are lots of approaches to do this. The one that we're taking today is still to keep that within the Rails application, but to define clear boundaries and interfaces between subsystems so that those subsystems can be maintained as a independent entity, even if it lives within the same code base. So we have not really adopted a microservices architecture. It just doesn't make sense with this particular product and this team. But what we have done is started moving towards encapsulating subsystems behind a well-defined interface. And then the final thing I want to mention is that any application that lives for this long is going to live within an architecture that is going to age. And even the DNSimple application starts to show some of its age in its design. And that's something that we are working to try to address even now and figure out how do we encourage the architecture to evolve, to further evolve, to follow new patterns that have come up, and to ensure that we can keep the application code fresh and understandable, and not just the architecture of the application itself, but the system as a whole. So that's it for today. I hope that you've enjoyed this presentation. The truth about maintaining a Rails application long-term is it is a challenge, but it's also very enjoyable because I think we benefit a lot from the opinionated nature of the Rails team and the fact that they've stuck to many of their original opinions in those ones that were good, but yet they've managed to evolve Rails over time as well. And so I think in a lot of ways, we as a team and we as a community as a whole have greatly benefited from this. And I, for one, really appreciate everything that has gone into making Rails over the years. And I look forward to many more years of running a solid Rails application. So thank you very much. I hope you have an excellent day.